We'll just go live. Yeah. So very good afternoon. Good evening to all of you. So I hope all of you are doing good and all of you are so safe. So yesterday we have started with general organic chemistry, right? So let us recall the yesterday's session but with two questions. I'm going to give you a recall test in this session. So the very first question is, what is the hybridization of carbon in ethyne molecule? Can anyone give me the answer for this? What is the hybridization of carbon in ethyne molecule? Yes, Pragati. Yes. So it is there in the YouTube. So each one is having separate channel. It will be uploaded over there. It is going live. Okay. Like for chemistry, we are having Avanti Live 2, right? So in the same way for physics, we are having Avanti Live 1. For maths and biology also, you're having like that. Got it? Okay. So the answer that you gave is exactly correct. The hybridization of carbon and ethyne molecule is sp. Okay. It is sp. Because the ethyne formula is C, triple bond C, H and H. And since carbon is having a triple bond around it, it is sp hybridized carbon. So these two carbons are sp hybridized carbon. The second question is cyclopropane homocyclic or heterocyclic? Yeah, the formula is CnH2n minus 2. Very good. Is cyclopropane homocyclic or heterocyclic? Is cyclopropane homocyclic or heterocyclic? What is your answer? Homocyclic? Very good. Cyclopropane means it is made up of 3 carbon, right? So the ring is formed by the same atom, which is carbon atom. So it is homocyclic in nature. Correct. Very good. So let's go ahead with the today's topics. So the learning objectives for today's session is we are going to learn what is a functional group. And secondly, we are going to discuss homologous series. And third, we are going to discuss the nomenclature. All right. So let me go ahead with the functional group. So what is a functional group and what it is? The atom or a group of atoms joined in a specific manner which is responsible for the characteristic chemical properties of organic compounds. Okay. So if I want to say this in a simple term, the reactive part of the molecule is called as functional group. Okay, so what is a functional group? The reactive part of the molecule is called as functional group. The reactive part of the molecule is called as functional group. Okay, so otherwise you can go ahead with this definition also. It is an atom or a group of atoms joined in a specific manner which is responsible for the characteristic chemical properties. Means at the point of functional group, where the functional group is present only, there only the chemical reaction will occur. Okay, so that's why I said that it is the reactive part of the organic compound or the molecule. Okay, some examples for some functional group containing compounds are phenol. So here we have OH group, right? So OH is the functional group, which is called as hydroxyl group. Okay, OH is a functional group. And here if you see, we have aldehyde. So C double bond OH. So this is the functional group. So this is the functional group. Aldehyde group is the functional group. And here if you see, in the third molecule, we have COOH. We have COOH. So which is called as carboxylic acid. So alcohol or hydroxyl group, aldehyde group, and carboxylic acid group. So these are some of the examples for functional groups in which the reaction will occur. Okay. So the chemical property of this particular compound depends upon the functional group of this molecule. Okay. Clear. So this we will study about some more functional groups in the upcoming slides. Okay, so there I will tell you what name you have to use as a prefix and what will be the suffix and what is the name of the particular compound and what is the reactivity order, what is the priority order and all we will discuss in the next class. I mean the upcoming sessions. All right. So now this is all about the functional group. So if somebody comes and asks to you what is a functional group means, you just tell it is the reactive part of the molecule. Okay, where the chemical reaction occurs. All right. Do you have any doubt from functional group? Shall we go for the homologous series? Shall we go for the homologous series? Suhra, Taushia, good evening. Farnas, you have joined little late it seems. Yes. Okay. All right. So let me go ahead with the homologous series. Okay. Homologous series. So what is meant by homo? I told that the meaning is same. The meaning for homo is same. Something is going to be same here. So let us see what it is. So let us first discuss the definition of homologous series and then we will move on to that. So homologous series is a group or a series of compounds, organic compounds, each containing a characteristic functional group forms a homologous series. Okay. It is a group or a series of organic compounds, each containing a characteristic functional group. Okay. Characteristic functional group. Suppose, for example, if I am taking alcohol, so what will be the homologous series of alcohol? So I have to start from one carbon onwards. So alcohol means you all know that OH will be attached, okay, to the carbon. If I'm having one carbon with OH attached, then it is called as methanol. Formula is CH3OH. If I have two carbons, what will be the formula? CH3, CH2 and OH. If I have three carbon, CH3, CH2, CH2OH. And if I have four carbon, it keeps on going like this. Okay, so what is happening here? We are adding CH2. We are adding a CH2 part here, CH2 group here, so that we are getting a series of compounds. And here it is a group of organic compound which is called as alcohols. Okay, the different types of alcohols are formed by repeating the CH2 units. Okay, so one more example. Let me go for one more example, alkane. So the one carbon containing alkane is called as methane, CH4. So if you add CH2 to this methane, what will you get? CH3, CH3, right? So I'm having CH4. If I replace one of the hydrogen by CH3, I will get CH3, CH3. Okay, or if I add CH2 to this component, if I add CH2 to CH4, what I will get? C2H6 I will get, right? C2H6 I will get. So C2H6 can be written as CH3CH3. Got it? So this will give C2H6, which is nothing but CH3CH3. And if you add one more CH2 to this, what you will get? You will get CH3, CH2, CH3. And add one more CH2, you will get the fourth compound. Okay. So now this is a group of organic compound. By adding CH2 units, we are getting this classification, okay, which is called as alkanes, okay. So the members of the series are called as homologous. The members of the series are called as homologous, and each and every compound is differing. The successive members are differ by a formula called CH2. okay, by a group or a series called CH2. Clear? And you are able to understand what is homologous series. You might have already studied this in your class 10th, right? I think so. Is it okay? Is it clear for all of you? Any doubt from this? So just by repeating the CH2 units, you will get a class of compound which is called as homologous series. Okay. Any doubt for anyone? Students? All right. Very good. So now let's go ahead with one question, and from that we are going to learn one concept. Okay. So this is the question. Okay. Thank you, students, for your response. So let's go ahead with this question. How many sigma bonds and pi bonds are present in each of the following molecules? So let me take another example. So C2H4 I'll take. Okay, C2H4. So here if you see in this molecule, all the single bonds are called as sigma bonds. All the single bonds are called as sigma bonds. So I have carbon, hydrogen, single bond here. So 1, 2, 3, 4 sigma bond. And if you are going for double bond, one is sigma and the other one is pi. One is sigma and the other one is pi. Okay. Clear for all of you. If you're having, so Taushia has given me the answer. So let me check whether that is correct or not. I will come to your answer later, my dear. Yeah, Anjum also. So just listen to the concept. Okay. So if I have C2H2, if I have C2H2, C triple bond C and H, right? So how many sigma bonds here? Means here I have carbon, hydrogen, sigma bond. And if I go for triple bond, one is sigma and the other two are pi bonds. One is sigma and the other two are pi bonds. Okay. One is sigma and the other two are pi bonds. So this is how you have to calculate. So if you're having only one kind of bond in your molecule, then all the bonds are sigma. If you're having a double bond, then one is sigma and the other one is pi. If you're having a triple bond, then one is sigma and the other two are pi. Okay. So all of you are saying that in a compound A, we have 4 sigma bond and 3 pi bond. Okay, let me check. Let me go for the solution. So first of all, when this type of question is asked, what you have to do, you have to draw the entire molecule with the bonds. Okay, I mean, you have to draw the complete structure of the molecule. Okay, you all know what is meant by complete structure, right? So drawing all the carbon-hydrogen bond and carbon-carbon bond is called as complete structure. So this is the first thing you have to do. Then you look for the sigma bond. So how many sigma bond we have? So here I have carbon hydrogen sigma bond 1. And in this triple bond, 1 is sigma. And here third one. And here also carbon hydrogen sigma. And here 1, here 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So totally how many sigma bonds we are having? 10 sigma bonds. Okay. Then you check for the pi bond. So in the triple bond, 2 of them are pi. 2 of them are pi and here 1 is pi. So 10 sigma bond and 3 pi bond. 10 sigma bond and 3 pi bond. So can you all able to understand now? So carbon-carbon sigma bond is 4, carbon-hydrogen sigma bond is 6. So totally 4 plus 6 is 10. 10 sigma bond and 3 pi bond. Clear? Able to understand? Can you all find out the mistake that you have made in your answers, students? So every time when this type of question is asked, this is very easy to answer. The only thing is concentration is important. Okay. You have to draw the complete structure of the molecule and you have to check for the carbon hydrogen sigma bond also. You should not look only the carbon sigma bond. Okay. Carbon hydrogen is also having sigma bond. So look into that and give the answer. Okay, let's come to the second compound. So Pragati is saying that there are 9 sigma and 2 pi bond. Okay. So let's go for the second compound. So this is compound number 2, right? So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Very good. 9 sigma bond. And here 1 and 2. 2 pi bond. Very good. Pragati, you are correct. The answer is correct. Taushya also. Taushya, Anjum, all of you have given me the correct answer. That's great. So we have totally 3 carbon-carbon and 6 carbon-hydrogen. So totally 9 sigma bond and 2 pi bond. Very good. Okay, so you will all, can you all able to find out if some other compound is given? Can you all find out the answer if some other compound is given to you? The compound may be aromatic, alicyclic, it can be anything. Okay. All of you can able to find out, right? Okay. So now I'm going to give you a previous year question from this concept and you are going to find out the answer for it. All right. So the question is on to you on the screen. The number of sigma bonds, pi bonds and lone pairs of electrons in pyridine respectively are. So what we have to find out? Sigma, pi and lone pair. And the molecule is pyridine. You all know what is pyridine, right? Yesterday we have seen, no? It is a heterocyclic aromatic compound. Pyridine is a heterocyclic aromatic compound. So you have to draw the compound like a benzene and you have to replace one of the carbon with a nitrogen. So you all know nitrogen will have one lone pair, right? Nitrogen will form 3 bonds and 1 lone pair because the valence number of electrons is 5 for nitrogen. So it has 1 lone pair. You check and tell me how many sigma bonds and pi bonds are here. Tell me how many sigma bonds and pi bonds are here. So which option is correct? Option A, B, C and D. Which is the correct answer? Which is the correct answer? Suhra is going for option C. Okay. What about others? Taujia is also going for option C. Okay. Parna is also C. Pragati is going for option B. Which is the correct answer? B or C? Which is the correct answer? Nandini, Vangtoy, Ajmala. What about your answers? Ishrat, Anjum. Is it option B? All of a sudden, everybody is going for option B. Okay. Option B is the correct answer. Option B is the correct answer. So finally, you guys have rectified your mistake, right? So listen. So we have 1, 2, 3, 4, 5 carbon and 1 nitrogen. And if you see the carbon, each carbon is having only 3 bonds around it, right? So let me draw this structure in an expanded form so that you can understand. So these are the pi bonds and these are the carbon atoms. So each carbon, if I take this carbon, it is having 1, 2 and 3 bonds around it. So each one is having 1 hydrogen atom attached to it. Each carbon is having 1 hydrogen atom attached to it. And nitrogen will not have hydrogen because its valence number of electron is 5 and 3 has been used for bonding and the remaining one is present as lone pair. Okay, so this is the complete structure of the molecule. Now you can check the sigma. So let me start with carbon hydrogen sigma. 1, 2, 3, 4 and 5. Okay. Then go for carbon carbon sigma. So each carbon is having double bond, right? So here we are having a double bond. So one is sigma. So already we have 5 and this is 6, 7, 8, 9, 10 and 11. there are 11 sigma bond. And how many pi bond? 1, 2, and 3. So there are 3 pi bond. And how many lone pair? We have 1 lone pair. Okay, so that's why option B is the correct answer for this question. Okay. Yeah, correct. So why you guys in the beginning you have opted for option C? May I know the answer? You thought that nitrogen will also have one hydrogen attached to it? Is that the reason? You guys thought that nitrogen will also have one hydrogen attached to it? Is it because of that you all gave option C or some other reason is there? Initially, Suhra, Taushia, Farnas opted for option C, right? Okay. So when you are going for the hydrogen, while filling up the hydrogen, you have to look into the atom. Okay, you have to look into the atom because atom and its valency is very important. Just like that, you cannot go for all the atoms in a way in which you are seeing the carbon. Okay, so you have to be very, very careful and have to get the answer. Got it? So this is all about the homologous series, functional groups, and the number of sigma bond, the pi bond calculations. All right. Go for a nomenclature. I'm going to jump into the nomenclature. So the first part of the nomenclature is trivial names of organic compound. So what is meant by trivial? Trivial means common name. Each compound will have common name and IUPAC name. Each organic compound will have two names. One is common name and the other one is IUPAC name. Okay. So what is a common name or what is a trivial name? So let me give you the story of this. Let me take one picture. So what is this? Citrus fruit. Citrus fruits have some chemical component inside it. Not a chemical component, it has one compound. Okay. And the compound is called as citric acid. So why they have named this compound as citric acid means because it is present in the citrus fruit. So that's why the name of the compound is called as citric acid. Okay. So the organic compounds were assigned names based on their origin or certain property. The compounds were assigned names based on their origin or some certain property. So here the name of the compound is given based on the name of the fruit. Okay, since citrus fruits have this compound, it is named as citric acid. I will give you one more example. So here you see, this is a red ant, right? The Latin word for this red ant is formica. Latin word for red ant is formica. And that ant sting, if you see, this is the sting, right? So it has a compound. It has a chemical compound. And that compound is called as formic acid. So that's why when the ant bites, what happens, that part will get bulged, no? If an ant bites you, you all have experienced that, right? So the part of that body will bulge out. So it is because of the acid present inside the sting. And we call that acid as formic acid. Why we are naming this as formic acid? Because it is present in the ant called formica. Okay. So naming is done on the origin. Naming is done based on the origin and using certain properties. So that's why those names are called as trivial name or common name of the compound. Okay. So here I have got a list of compounds and their common names for you. So CH4 is called as methane. And if 4 carbons are there, then it is N-butane. Okay. If one is branched, then it is isobutane. If I have 5 carbons in a branched form, it is neopentane. Don't worry. We will practice. We will practice all these things in the reactions, in the nomenclature, in the upcoming classes so that you can get used to it. So don't worry. Okay. So if a compound has HCHO, it is called as formaldehyde. Okay, HCHO containing compounds are called as formaldehyde. And here acetone. CHCl3 is chloroform, acetic acid. Acetic acid is present in vinegar, right? CH3COOH is present in vinegar. And C6H6, we all know it is benzene, anisole, aniline, acetophenone, ethyl methyl ether. So these are some of the examples and their common names. Okay. So this is all about the common name. Now let us move into the very important system of nomenclature called IUPAC nomenclature. Okay. So can anyone tell me the full form of IUPAC? This is the systematic method of naming an organic compound. This is the systematic method. So if I compare the two systems, the common naming and IUPAC naming is the systematic method of naming an organic compound. Okay. So do you guys know the full form of IUPAC? Anybody? Anyone? Very good. Very good. So the full form is International Union of Pure and Applied Chemistry. Okay. The full form is very important. So learn. International Union of Pure and Applied Chemistry. So the names are correlated with the structure such that the reader or the listener can deduce the structure from the name. So if you know the rules of IUPAC to find out to apply in some chemical compounds, just by looking into the name of the compound, you can find out the structure. Or by seeing the structure, you can find out the name. Because this IUPAC, this particular people, this group of people have some set of rules to be followed. If we study those rules, then we can also able to find out the name of the compound or the structure from the name. Okay. So we will study those rules in the next slide. So now for example, let me take one compound. So here I have taken ethane, C2H6. Since this compound has two carbon, it is called as ETH, and that those two carbons are attached with a single bond. So it is ending with ANE. So it is ethane, which is an alkane. Okay. So now let's go for the rules. Okay. Let's go for the rules. Before entering into the rules, I would like to say some more information about this. So as I have already told, it is a systematic name of an organic compound. It is derived by identifying the hydrocarbon and the functional group attached to it. Okay, it is derived by identifying the hydrocarbon and the functional group attached to it. Okay, so listen, this is a compound. This is not the complete compound. This is the parent chain, the longest chain, the more number of carbon containing chain. So this is the parent chain. And I have some substitutions in this compound. Now this is the complete formula or complete structure of this molecule. So here I have three substitution. Okay, three substitution. CH3. CH3 is a branch. Okay, and OH and Cl are the functional groups. OH and Cl are the functional groups. Okay, so the parent chain is made up of hydrocarbon. So in the parent chain, you see we have only hydrogen and carbon, right? So it is a hydrocarbon. So the compounds containing carbon and hydrogen only are called as hydrocarbons. And in this molecule, we have carbon-carbon single bond only. If only carbon-carbon single bond is present, then it is a saturated compound. If we have carbon-carbon double bond or carbon-carbon triple bond, then those are called as unsaturated compounds. Okay. So for saturated compounds, the IUPAC name for that particular saturated compound is alkane. IUPAC name for a homologous series of such compound is alkane. And for carbon-carbon double bond, alkene. For carbon-carbon triple bond, it is alkyne. Okay, so all these names, alkane, alkene, alkyne, were given based on the IUPAC people only. Okay, clear for all of you? So a compound may have only one chain of bonds or it may have branches also. So the naming of the IUPAC naming of a compound is done in such a way by looking into the functional group and the hydrocarbons. All right. So let's go ahead with the next slide. Now I'm going to give you the skeletal structure of the IUPAC system of nomenclature. Okay, the skeletal structure of the naming. So IUPAC naming will have a secondary prefix, primary prefix, root word, primary suffix, and secondary suffix. Okay, so what is this? This is the skeletal structure. This is the skeletal structure. Okay, to name the IUPAC nomenclature. Okay, so let me start with the root word. So what does the root word indicate? It indicates the number of carbon atom in parent chain. Root word indicates the number of carbon atoms in the parent chain. Okay, I will come to the root words later in the next slides. First, let me explain each and every term which is here in the skeletal structure. So root word means number of carbon atom in the parent chain, in the longest chain. Okay. Then coming to primary suffix. The primary suffix talks about the unsaturation, whether it is alkane or alkene or alkyne. And secondary suffixes talks about the main functional group. Okay, in the previous compound I have OH, right? So that OH is the main functional group. Secondary suffix talks about that. And the primary prefix says whether the compound is a cyclic compound or not. If it is a cyclic compound, then you have to use the prefix cyclo. So for example, yesterday we have discussed, right? So what is this? This is a cyclic compound. So 3 carbon containing cyclic compound. So we are naming this as cyclopropane. Cyclopropane. So this is the root word. And here we are using a prefix. And the prefix is cyclo. Okay, prefix is cyclo. Clear for all of you? Then the last one is secondary prefix. Secondary prefix is the substituents with locants. Substituents with locants. I will teach all these things. Clear? Is it clear? So if a compound is having the primary prefix or secondary prefix, if a compound is having functional group, you have to use the name accordingly. And if it is having some substituents or if it is a cyclic compound, you have to go accordingly. Okay, you have to follow this order. Secondary prefix, primary prefix, root word, primary suffix, and secondary suffix. All compounds will not have all the 5 things. Okay, so some compounds may have only primary suffix. Some compounds may have only primary prefix and primary suffix along with the root word. Okay. Some compounds will have only root word and secondary suffix. So, it depends on the compounds. It depends on the compounds. If it is having all the 5 terms, then you have to follow this order. Okay. You have to follow this order. So, do you guys have any doubt here? Do you guys have any doubt here? Shall we go for the next slide? Okay. Okay, that's great. So now let me talk about the root word in detail. Okay. So what is root word? It is the number of carbon atom in the parent chain. Number of carbon atom in the parent chain. So if the parent chain has only 1 carbon, then the root word to be used is Smith. Okay. If the parent chain has 2 carbon, then the root word is eth. That's why for ethane, we used ETH, right? So C2H6. And if it is having 3 carbon, prop. 4 carbon, but. 5 carbon, pent. 6 carbon, hex. If you're having 7 carbon, it will be hept. Okay. If you're having 8 carbon, it will be oct. If you're having 9 carbon, it is non. If you're having 10 carbon, it is dec. Okay, it is dec. So these are the, yeah, very good, Farnas. Pragati, I will tell you what is a locant. So when I'm teaching the rules to find out the naming, that time I will tell you what is a locant. Okay, don't worry. Is that okay? Clear? Yes. Okay. So these are the root words. These are the root words. You all have to memorize the root word because it is this nomenclature part is very important for all the organic chemistry lessons of your syllabus. Okay, not only in class level. So this is a basic lesson to your entire organic chemistry. Okay, so we have only two organic lessons in class 11. One is this GOC lesson and the other one is hydrocarbons lesson. If you go for 12th class, the first organic chemistry lesson will be haloalkanes and haloarenes. Then after that, you have three more lessons. Okay, all those are the, what to say, the continuation of your class 11. So all those lessons will have the nomenclature. If you're studying about hydrocarbon, you will study the nomenclature first. Then only you will study about the hydrocarbon. If you're going for haloalkanes lesson, first you have to study the nomenclature of haloalkanes. Then only the reactions, the other properties will come. Okay. So likewise, if you go for alcohols lesson, you have to first study the nomenclature. So each lesson will have the nomenclature part at the first. So without knowing this basic, without knowing this lesson, those things will be very difficult for you. Okay. So because you can expect at least 2 questions to 3 questions from nomenclature in your exam. Okay. So, maximum I'm saying. Okay. Maximum. You can get more than this also. Okay. You can get more than 3 questions also, but at least one or two will be asked from the nomenclature. Give more importance to nomenclature and study. If you're having any doubt, please feel free to ask me and get clarified. Okay, don't take your confusion, don't take your doubts from nomenclature part to the next lesson or to the next class. Okay, if you want to ask anything, just ask and clear your doubt in this class itself. All right. So you all have memorized the root word, right? So from carbon number 1 till carbon number 9. Any doubt you have? Nothing to worry about the concept. It is just memorizing only. 1 means meth, 2, eth, 3, prop. That's all. Okay. So, okay, fine. Let me go for the next slide. Now, let me take an alkane. So, this is an alkane. How many carbons does this alkane has? 2 carbon. And carbon-carbon single bond. This is a carbon-carbon single bond containing compound. So, what I have to do? I have to take the root word. The root word is eth. Okay. And the primary suffix. Primary suffix is alkane. So it ends with ane. So the name of the compound is ethane. Okay. ETH is the root word. Ane is the primary suffix. Okay. So it is named as ethane. Okay. Very good. So coming to the second compound, alkene. So in alkene, in this alkene, I have 2 carbon with carbon-carbon double bonded system. So if I'm having a double bond, the suffix should be ene. So the name of the compound is ethene. Yeah, it is ethene. Then if I go for 2 carbon containing alkyne, it has triple bond. So the primary suffix will be yne. Yeah, so it is called as ethyne. Okay. So all these 3 compounds are very easy for you guys, right? All right. So all of you have given me the correct answer for all the 3 things. That is really great. So this is how we have to name the compounds. Okay. So now let's go ahead for the IUPAC naming for straight chain hydrocarbon. Straight chain hydrocarbons. Got it? So the names of such straight chain hydrocarbons are based on their chain structure. Okay. So hydrocarbons means mainly here I will talk about alkanes. So the suffix to be used is ANE. Okay, ANE. Let me give you a tabular column. For methane, for 1 carbon containing alkane, it is methane. 2 carbon ethane, 3 carbon propane, 4 carbon butane, 5 carbon pentane, 6 carbon hexane, 7 heptane, 8 octane, 9 nonane, 10 decane. If I have 20, then it is icosane. If I have 30, it is called as triacontane. So 10, 20, 30, 10, all these are 10 will be used in some cases, but 20, 30, those things will not be there. Okay. But you should know the name. Okay. For 20 carbon containing and 30 carbon containing systems also, because it is given in the book, right? So you should know. Clear for all of you? So for straight chain hydrocarbon, if I have propane, propane means it is CH3, CH2, CH3. It is arranged in a straight chain manner. So propane. If I have butane, CH3, CH2, CH2, CH3. This is butane. If you want to draw pentane, CH3, CH2, CH2, CH2 and CH. This is pentane. Like this, you can keep on writing the structures of the straight chain hydrocarbons. Okay, very easy. So now let's go for the nomenclature of branched chain alkenes. Nomenclature of branched chain alkenes. So here only we have to follow some set of rules. Okay. So branched means, what is meant by branched? Small chains of carbon atoms are attached to one or more carbon atoms of the parent chain. So we will have a parent chain. So in that parent chain, we have some number of carbon atoms. Okay. So to that carbon atom, some branches can be attached. Okay. That branch is the small chain of carbon atoms. Small chain of carbon atoms. So let me give you one example. So this is a compound. This is a branched chain hydrocarbon. So here you see, this is the parent chain. Longest chain. More number of carbon containing chain is the parent chain. And what is this? This is a small group. It is a small chain which is attached to one of the carbon in the parent chain, which is called as branch. This is called as branch. Okay. So let me give you one more example. See here. Here if you see, the parent chain is this. This is the parent chain. So parent chain means more number of carbon containing chain. More number of carbon containing chain. Nandini and Pragati, you guys are going very advanced, you know. So this is the parent chain because it has 6 carbons and these two are the alkyl groups. These two are the small chains. So the small carbon chains are called as alkyl groups. I'm saying no, the branches are called as alkyl groups. So how we are getting this alkyl group? We should know the reason for that also, right? How we are getting these alkyl groups. For example, if I have methane, I have 4 hydrogen. If I replace one of the hydrogen, by one method, by another group, if I replace one of the hydrogen by some another group, then it will form some other compound. But if I remove that hydrogen from this compound, what I will have? I will have only CH3 bond. That's all. So since it has been derived from methane, it is called as methyl. It is called as methyl. Pragati, your name for the second compound is wrong. Just look into the parent chain that I have took. Parent chain has 6 carbons, no? Okay, I will come to that later. So let me discuss about this alkyl groups first. So how do we get an alkyl group? We are taking an alkane and removing the hydrogen and we are getting alkyl. Okay, I am taking methane, removed one hydrogen and I have got methyl. Likewise, ethane will give ethyl. Propane will give propyl. Okay, so each alkane, you can take any type of alkane you can take and remove the hydrogens and they will give you the corresponding alkyl groups. Okay, so I have got some alkyl groups for you. So from methane, we are getting methyl. From ethane, ethyl. propane, propyl, butane, butyl, decane, decyl. So only for methane and ethane, we have one alkyl group. Okay, if I go for propane, butane, pentane, they will produce different types of alkyl group. They will produce different types of alkyl groups. The alkyl groups can be branched also. Okay, if I go for 3 carbon containing system, you see 3 carbon means CH3, CH2, CH3. This is propane. This is your propane. This is propane. Okay. So propane has 2 different types of hydrogen. One is terminal hydrogen and the other type is internal hydrogen. If I remove the terminal hydrogen, what will I get? CH3, CH2 and CH2 bond. Okay, this is one type of alkyl group and this is called as N-propyl. This is called as N-propyl. In the other way, what I can do, I can remove the hydrogen from the internal carbon. So what will I get? CH3, CH bond and CH3. So this is called as isopropyl. This is called as isopropyl and this is isopropyl. I have written this bond in the right hand side and CH3 here. Okay, both are same only. So the alkyl groups can be branched also. So 2 different types of alkyl groups can be drawn from the 3 carbon containing propane. Is it clear for all of you? Do you have any doubt from this? Do you have any doubt from this? Shall I go for the alkyl groups of butane? Yes. Okay. So in butane, how many carbons we have? 4 carbon, right? So the formula for butane is CH3, CH2, CH2 and CH3. So here I can take 4 alkyl groups. So the first alkyl group is the removal of the end hydrogen, terminal hydrogen. So remove that hydrogen. See with CH3, CH2, CH2, CH2 bond. This is the first alkyl group, which is called as N-butyl. N means normal. N denotes normal. Okay. And secondly, what you do, remove the last before hydrogen. So here you will get CH3, CH2, CH bond and CH3. So if I remove the last before hydrogen, this is called as secondary butyl. This is called as secondary butyl. Okay. Now, third what you do, take one of the CH3 and attach to this carbon. So I will have CH3, CH, CH3, CH2 bond. So take this CH3 and try to attach with this carbon. Replace one of the hydrogen with CH3 group and write the remaining thing. So you will have CH2 bond. This is called as isobutyl. This is called as isobutyl. And the 4th alkyl group is attaching 3 methyl groups to 1 carbon. Attaching 3 methyl groups to 1 carbon. So this is called as tertiary butyl. This is called as tertiary butyl. So if I have CH2 bond in a straight chain manner, it is N-butyl. If I have CH bond, it is called as secondary butyl. If I have C bond, it is tertiary butyl. And if I have CH2 bond with 1 branch, it is called as isobutyl. Okay. So nothing to worry. So just to go through, okay, revise again and again. Okay, revise again and again. Try to memorize. It will be stored in your mind. Okay, you don't have to worry. Clear for all of you? Just by looking at the first side, you cannot memorize. So learn again and again so that you will not get confused. Okay. Any doubt from this butyl for anyone? So the propyls and the butyls are very important for solving the nomenclature in all the lessons. Okay. If you want to write this on your notebook, you can take it down. You can take it down. So these are the 4 alkyl groups of butane. Shall I clear the things that I have written on the screen? Or if you want to write down? To write down this in your notebook, students? Guys, tell me, say yes or no. Are you guys writing or shall I go for the next thing? What about others? Writing. Okay, let me know once you are done with it. Nandini is asking me to clear. Ajmala is writing. Okay, I'll wait for some time. If you are writing, you write. If you want to take the screenshot or the photo, you can take it and write it later also. Okay. Shall I go ahead? I will finish the class now. Okay, just give me 1 or 2 minutes. I will finish the class. All right. You cannot take screenshot. Okay, my dear. You write. You write. I'll wait for you. Okay, okay. Got it. Got it. Write fast. Write fast. Others can answer for the questions on the poll. Without wasting the time, others can answer for the questions which I have launched on the poll. So Ajmala completed. Okay, that's great. So these are the 4 butyls and 2 propyl. Okay, so please study this today itself. Please study this today itself. Okay, so let me show you the butyl. So this is secondary butyl, isobutyl, and tertiary butyl. Secondary butyl, isobutyl, and tertiary butyl. Okay, in tertiary we won't have this hydrogen. And the other one is N-butyl. Okay. One more thing I want to say. With that, I will close this. So we have one very important alkyl group with 5 carbon. That pentyl, neopentyl. So draw tertiary butyl, and attach CH2 to tertiary butyl. So that you will get neopentyl. Okay. Attach the CH2 group to tertiary butyl. You will get the neopentyl. Clear for all of you? It's very easy. So draw the tertiary butyl and attach CH2, you will get neopentyl, and this is one of the alkyl group which we will be using in the compounds. Okay. So now this is enough for today, and from tomorrow onwards, we will go to the rules. Rules to name the branched chain hydrocarbons. Okay. Do you guys have any doubt from today's session? Is everything clear? So again and again, I'm saying you, if you're getting any doubt in organic chemistry right now, you should ask. You should ask. Okay. All right. So go through the concept that we have discussed today and yesterday also before coming to the next class. So see you with the IUPAC rules in the next class. Thank you. Take care. Bye-bye. Thank you for listening.